Now, although it's possible to access an inner class from outside the outer class, that's usually not what happens because the motivation for having an inner class in the first place is usually because we have the intention of only accessing it from within the outer class. Since that's the case, it's not necessary in many cases to actually assign a name to the inner class, and that gives rise to what we call an anonymous inner class, that is, an inner class that does not have a name associated with it. Such an anonymous inner class is still going to be extending a superclass or else implementing an interface, but it won't be able to have explicit extends or implements clauses in this case. Expect any abstract methods that might exist in the superclass that an anonymous class is extending or in an interface that the anonymous class implements have to be provided implementations for in the anonymous class. Since way back you learned that constructors have the same names as their classes. So what do we do when the class doesn't have a name? Because that's what happens in the case of an anonymous inner class. There's no name associated with it. Well, it turns out then that we're always going to use the noarg constructor from its superclass to create an instance of the anonymous class. But what if the anonymous class doesn't extend another class? What if it is only implementing an interface? Well, then what happens is the constructor used will be the root object class. So as you can see, there's a number of issues that arise when there's no name associated with a class. And now we've addressed most of those, but there's one more left, and that's what happens to the bytecode. Ultimately, the compiler needs to compile bytecode for our class, even if it has no name. The strategy here used is as you see on this slide. We use the naming convention outer class name $, and then n.class, where n is the occurrence of an anonymous class that refers to this one. In other words, if we only have one anonymous class, n will be 1. If there's two, the first anonymous class will be 1, the second anonymous class will be 2, and so on, up to n. So for example, if we had two anonymous classes inside a class called test, then the first would be compiled as test $1.class and the second as test $2.class. An inner class intended to be a listener can be shortened by using anonymous inner classes because there's no name associated with the class in that case. The way this works is we declare and create an instance of the class in one foul swoop. That is, we can declare an anonymous inner class in the way you see at the bottom of this slide. So we simply say new, and then we give the superclass name or the interface name depending on whether we're extending a class or implementing an interface. And then in curly braces, we simply provide the implementation or override the methods and so on that we would need to do. Notice then that what we've done is we've left out the declaration and we've left out giving it a name. Well, it sort of makes sense because after all it's anonymous. So therefore we go straight to using the new keyword. The compiler of course immediately infers the declared type based on the actual type that you see here after the new keyword. And since there's no name or an equal sign, it understands that we don't want to give this a name. So here we see a comparison between having an inner class that's named and an inner class that's anonymous. On the left-hand side in diagram A, we have an inner class that has a name called enlarge listener. You can see that at the bottom half of that section we have class enlarge listener, so we're actually defining a class and giving it a name. It's an inner class because it's inside of the big class that starts public class anonymous handler demo extends application. So that's a big class, and this other class is inside of that larger class, making it an inner class. But at this point it has been given a name, so it's a named inner class, and because it has a name we can refer to it in our set on action invocation. We can pass it as a parameter and say new enlarge handler. Notice that the object associated with this is anonymous already because we don't give it a name. We simply say that the argument is an object of class enlarge handler by simply saying new enlarge handler. So the class has a name, it's not anonymous. The object that we've plugged in does not have a name, and it is anonymous at this point. Now in diagram B, both become anonymous, and we'll see how that happens now. So turn your attention to diagram B then. You can see that we have the same outer class, that is public class, anonymous handler, demo, etc. And within that outer class, we have an inner class, but now it's not only inside of the anonymous handler demo class, it's actually right inside of the call to, or the invocation of set on action. It's right plugged in where the parameter would go. To help you understand this, instead of um, just removing things that don't belong there, they've been left in but have strikeout appearing over them to indicate that they're not supposed to really be there. They're just shown to sort of indicate to you what's missing now and why this has become anonymous. So let's look carefully at the argument to set on action. So start at the line that says button enlarge dot set on action. Now we're supposed to have, starting in with a round parenthesis, a pair of parentheses that encloses a particular object which represents an object of a class designed to handle the event that's going to take place here. We're still making that object anonymous by just going straight into, say, new. But now the class is anonymous too, because rather than give the name of a class, we're going to leave off class enlarge handler implements, and we're simply going to put the name of the interface being implemented, event handler, and then we're going to have as its generic type, we're going to plug in an action event because that would be the appropriate type for set on action. There's no arguments for this, so you can see we have an empty pair of parentheses highlighted in blue for you at this point. And then we go straight into the implementation. So we have an opening curly brace, and in the implementation we define a public void function called handle that's going to handle the event, and it indicates here that the argument that we're passed is little e, and it's an object of class action event. Then our definition for this for this method here that we're providing is simply circle pane dot enlarge. So now what you want to do is mentally remove the part that's struck out, the class enlarge handler implements. Just remove that completely, and what you have left is what would constitute an anonymous inner class.